The authors acknowledge that this podcast was recorded on the traditional, unceded lands of the Lekwungen peoples. Hello, and welcome back to Stories from Space. I'm your host, Matt Williams. And today, I wanted to address a subject that is very much on our radar right now, and that is the subject of Three-Eye Atlas, and in general, interstellar objects. And for those following the news, they will be immediately familiar with what I'm talking about. Three-Eye Atlas is the latest interstellar object that we have managed to detect in the past 8 years. It began in 2017 with Oumuamua, which was followed 2 years later by Two-Eye Borisov, and Three-Eye Atlas now rounds it out as a trilogy of objects that are passing through the solar system, and they are representative of a much, much larger population of objects that do this on a regular basis. So in essence, this is not the third interstellar object to pass through our solar system. It is merely the third one that we are aware of. And its detection has shown just how quickly our ability to detect, track, and study interstellar objects has come. What's more, this object has once again led to some controversy regarding certain anomalous or unexpected readings that have prompted some individuals to speculate that, much like Oumuamua, this could be a interstellar spacecraft or a piece of debris that is essentially junk from a extraterrestrial civilization that's passing through our solar system, and proof that we are not alone in the universe. So, in the course of this episode, I hope to break down everything we know about interstellar objects at this point, why there is speculation about ISOs being extraterrestrial spacecraft, and how these arguments are really very tainted by misinformation and a very sensationalist, clickbaity mentality. However, the primary purpose here is not to promote or completely debunk or take apart any speculation or theoretical thought about whether or not ISOs could in fact be resolutions to the Fermi paradox, proof that we're not alone in the universe. I would like to introduce the caveat that, in fact, this will be strictly about what is known scientifically, and I fully intend to explore the ambiguities or the unexplained aspects of certain encounters that have led to these thought experiments, which, of course, were proposed in the first place by Harvard professor Avi Loeb, who was a guest here on this very show, and how his own writings about Oumuamua and again about Three-Eye Atlas, how they are related and how these thought experiments are not claims to alien technology and alien spacecraft, but rather just that, thought experiments, and how and where they are useful and where they are not. So, having cleared all the caveats and addendums, let's get into it. What are ISOs in the first place? Well, simply put, the name describes them aptly. They are objects that are interstellar in nature, meaning that they are asteroids, comets, or, as recent studies have shown, potentially rogue planets, which are apparently very common in the Milky Way. In any case, the objects themselves, these would have been kicked out of their solar system, their place of origin, due to gravitational perturbances, possibly due to a passing star system, or a close flyby with a rogue planet, as mentioned. And from there, they became unbound objects that traveled from star system to star system. And in the case of comets and asteroids, some of them would have been captured by our sun's gravity or Jupiter's gravity and stayed in the solar system. And the subject of these objects has become something of a rather big deal in recent years because in 2017, the first ever interstellar object was detected. And that was the famous Oumuamua, which was detected on October 19th, 2017 by the Pan-STARRS telescope at the Haleakala Observatory in Hawaii. And the name reflected that because, per tradition, objects will be named in honor of the observatory that found it. And given that the Haleakala Observatory is in Hawaii, Oumuamua, a indigenous Hawaiian name, was selected, which roughly translates to scout, which, as it turned out, proved to be very, very significant for reasons I will get into in a minute. However, it's interesting to note that originally the name Rama was suggested, which is the name that comes from the novel Rendezvous with Rama by Arthur C. Clarke. And for those unfamiliar, this novel, it concerns the arrival of an extraterrestrial spacecraft in the solar system in the not too distant future and humanity's efforts to explore it. And this novel is, perhaps, Arthur C. Clarke's best known, most established work, with the exception of 2001: A Space Odyssey. And of course, all of this would prove to be very, very significant as speculation as to what the object was really began to take off and snowball in the months and years that followed. And this was in part based on the fact that the data scientists were able to obtain on Oumuamua was quite limited because the chance detection by the Pan-STARRS Observatory that managed to catch a glimpse of Oumuamua as it was already on its way out of the solar system. Nevertheless, what they saw was rather interesting, if not particularly telling. When it was initially detected, scientists believed that based on its brightness, that it was a comet. However, closer examination showed that it had no coma, no halo of sublimated gas, which is the norm for comets, and it had no tail. So basically, there were no volatiles that were outgassing and creating a cloud around it. And so they changed the designation to an interstellar asteroid. And this seemed to also be backed up by spectra, which indicated some metallic properties, which one would expect from an asteroid. However, as the comet was making its way out of the solar system, scientists noted that it was speeding up. And there didn't seem to be any likely explanation for why this was happening, because the last observations we had of this object, it didn't indicate that there was any outgassing. Again, what one would expect from a comet to explain why it's speeding up. But this was comet-like behavior, so therefore the debate was now on. What exactly was this object? Is it a comet? Is it an asteroid? Is it some kind of entirely new object we'd never ever seen before? And the only certainty there was that third part there. Yes, absolutely. This is an object unlike anything we've ever seen. Now, in the first place, the mere fact that Oumuamua was detected indicated that such objects are statistically significant, meaning that many of them pass through the solar system on a regular basis. And this was something that was addressed in a paper that included Marshall Eubanks of the Institute for Interstellar Studies and Professor Avi Loeb of Harvard University, who was also the founder of their Institute for Theory and Computation. And together with researchers from a number of institutes and universities, they ran numerical simulations to determine just how common ISOs, interstellar objects, are and how often they pass through the solar system. And their results indicated that at least 7 do with every passing year. So by merely detecting this object, scientists now knew that they were likely to be very common and that there'd be opportunities to see more in the near future. And that certainly proved to be the case. And much like gravitational waves, the discovery of this object was revolutionary. It meant that astronomy had now expanded to include objects that were previously theoretical. And now we had proof that they, in fact, existed and that solar systems exchange material through comets and asteroids on a regular basis, which had significant implications for panspermia, or the notion that the building blocks of life are distributed throughout our galaxy via interstellar objects. But getting back to Oumuamua, all that anomalous behavior, it immediately began prompting some interesting and very speculative theories on what it could be. And one of the first was a paper that suggested that it was a hydrogen iceberg. And hydrogen, in its frozen form, when it sublimates, it does not release a visible gas the way that an ordinary comet, which is made up largely of water and other volatile elements. So that would explain why it didn't have a coma or a tail. And it would also explain why it sped up, because solar radiation hitting its backside would mean that it would sublimate more, and we would not see the gas, but it certainly would be there and it would account for the acceleration. However, this theory proved to be very untenable in one respect. While it could explain the brightness and the lack of a halo and a tail, the existence of hydrogen icebergs in the universe, statistically speaking, such objects would be so incredibly rare because neutral hydrogen exists everywhere in the universe and it's in its gaseous form. For it to be frozen solid would require temperature conditions that are incredibly rare. And to put some numbers to that, basically the freezing point of hydrogen is minus 259 degrees Celsius, or roughly minus 434.5 degrees Fahrenheit, which is roughly 15 degrees warmer than absolute zero. And like I said, that temperature is rather rare in the universe. In addition, hydrogen's boiling point is just 7 degrees more, minus 253 approximately degrees Celsius, or minus 423 degrees Fahrenheit. So, such an object, if it could survive passing through interstellar space, would likely have sublimated long before it reached its closest path to the sun, and would have had to have been very massive in order for any of it to survive. So that theory was not on the table for very long. Another theory came forth that said that it was a conglomeration of objects, which likely included rocky material with metals and icy material, and this came to be known as the cosmic dust bunny theory. And so this aggregate material, the scientists argued, it would have passed around the sun, and the mixed material there would explain why it was both bright but had asteroid-like qualities revealed in its spectra, and why it sped up suddenly, that there was outgassing, but we just didn't see it. However, this theory too didn't stay on the table very long because the idea of aggregate material coming together and surviving its closest pass with the sun rather than breaking apart in all directions, it really didn't seem likely. And then there was yet another theory that said, well, it was a fragment of a larger object that broke up after it passed around the sun. But again, similar problems. For this fragment to be experiencing comet-like behavior, it would have formed a tail. We would have seen it outgassing as it was whooping by Earth on its way to the outer solar system. So basically, all of these theories, they could account for two aspects of the unexplained behavior, but not all three, right? It has no tail, but it's bright. It's metallic, but it's sped up. So that is when Professor Abraham Loeb suggested something truly exotic. And he said, what if, just as a thought experiment, Oumuamua was an artificial object, either a spacecraft, similar to what he and other scientists were working on for Project Starshot, or a piece of debris, because the scientific community was now kind of reaching a sort of consensus, saying that it must have been radiation pressure that caused the acceleration of the object. And what kind of objects respond to radiation pressure alone? And he used an example. There was a piece of debris from the Apollo era that had been floating around the moon. And this object was noted for a sudden acceleration that it experienced when it came into contact with sunlight. And this particular object had been observed experiencing a change in velocity, which coincided with it getting hit by the sun. And so Loeb used this as an example to illustrate how debris from other civilizations, how it could be a very common element in the universe. And much like naturally occurring interstellar objects, some would get booted from its respective solar system and end up in other places. And he explained all this in a paper with his then postdoc, Shmuel Bialy. And what they asserted, it basically fit the facts. On the one hand, if it was a piece of metal debris or a possible light sail, that would explain its brightness. In addition, he argued that the profile of Oumuamua, which initially astronomers thought that it looked cigar-shaped, elongated and narrow, but subsequent analysis indicated that it was more likely circular. And this too, as Loeb argued, that shape fits the profile of a light sail. And Professor Lubin of UC San Diego, who was also a part of Project Starshot, he had been working with these concepts for years, how a light sail could be propelled by lasers in order to achieve really high velocities, 20% the speed of light, and reach nearby stars in a human lifetime. And that, of course, became the basis of Project Starshot. And he, too, in his designs, one of which he was working on for NASA, it featured a light sail that was circular in shape. So, as Loeb and Bialy argued, that would explain its brightness and its profile. It would also explain why it didn't have a tail and why it accelerated at the end. And this was a very, very controversial theory because, of course, many people in the media ecosystem began using this idea and saying that a professor said it was aliens. And, of course, the UFO conspiracy theorists and so forth, they began to argue much the same thing, that this was proof of aliens' existence and contact. And of course, they were all misusing what Professor Loeb actually said, which was, as a thought experiment, we should consider the possibility that maybe Oumuamua was an artificial object. And he too flat out said, all that we know for certain is that it's a type of object the likes of which we've never seen. And the scientific community, they hit back. They continue to argue the theory that this was a type of comet whose tail, coma, and sublimated material we could not see, which came to be known as dark comets. And another paper came out arguing, instead of a hydrogen iceberg, that it was a nitrogen iceberg. So the kind of material that one finds in the outer reaches of solar systems, much like our own, beyond Neptune's orbit, what's known as the trans-Neptunian region, conditions are cold enough that nitrogen will freeze solid, and that is why bodies like Pluto and Charon are largely made up of nitrogen ice. And so are the many, many objects that populate the Kuiper Belt and the Oort cloud, which is where our comets in the solar system come from. And so this theory also explained all those behaviors, but of course Loeb, he challenged that by saying that statistically speaking, such objects cannot be so commonplace, and argued that the spectrum behavior was not consistent with nitrogen iceberg. And there was rather fierce debate on all these points between himself and his postdocs and, of course, the scientific team that proposed the nitrogen iceberg hypothesis. So at that point, it did seem like there was a sense in the scientific community that it was in fact a dark comet, and that Professor Loeb had jumped the gun by suggesting that it could have been an extraterrestrial spacecraft or something that was artificial in origin. And some of the pushback, rather interestingly, came from the SETI community, in particular Jill Tarter, a leading SETI researcher and theorist who was the subject of Carl Sagan's book Contact. The main character in that, which is played by Jodie Foster, is based on the life of Jill Tarter. And she and other SETI researchers took Professor Loeb to account, saying, you violated one of the cardinal rules of SETI. You don't say it's aliens unless you have the necessary evidence to back that up. To quote Carl Sagan, extraordinary claims require extraordinary evidence. And at the risk of editorializing, though, those rules really were concerned with radio SETI, in that the SETI community would not announce that they had made a finding that could indicate the possibility of aliens when they were examining radio transmissions unless they were absolutely sure that messages that were detected could not be of natural origin. And these rules, these were written at a time when SETI consisted of listening to radio waves from space. So they really hadn't been updated for the study of interstellar objects yet. Nevertheless, they had a point. By saying it could be aliens, Loeb was stirring the pot. In any case, things were much less controversial, much less stirred up when the second interstellar object was detected in 2019. And the mere fact that another one was detected just 2 years after the first, that confirmed that these were statistically significant objects. The study that I previously mentioned, involving Eubanks and Loeb and other researchers, it was conducted in 2021, and it used both detections as a basis for determining how common they were. And Borisov really presented no mysteries. When it was initially spotted, scientists noticed that it was outgassing. It had a visible halo and tail, and that its composition was very similar to comets in our own solar system, except for one minor difference, which was that it had high levels of carbon monoxide. And like Oumuamua, they were able to determine that this was an interstellar object based on its trajectory and its overall path through the solar system to beyond. And because of the lack of ambiguity, Borisov came to be designated as the first interstellar comet. And unfortunately, it would be another 6 years before we detected the third and latest interstellar object, which is 3I Atlas. With Atlas, scientists had the benefit and the good fortune of seeing it as it was making its way towards the sun. So it had not yet made its closest pass and wasn't on its way out of the solar system yet, which provided ample opportunities for study and analysis. And there's still far more to come. Because Atlas had made its closest pass to the sun on October 30th and is currently coming around and will appear on the other side as it makes its way out of the solar system. And during that time, on December 19th, on or about, NASA says it will pass by Earth. It'll make its closest pass to Earth, and it will be at a distance of 1.8 astronomical units as it does so. Basically 1.8 times the distance between the Earth and the Sun, which is between the distance of Mars and the asteroid belt from the Sun. So not exactly a close pass, but nevertheless a pass that will allow scientists to observe it some more. And it is expected that a lot more data will be available because, of course, after making its closest pass to the Sun, it will be sublimating more gaseous material, and we'll be able to learn more about its composition, especially material that's beneath its outer icy shell. And that's likely to reveal a lot about the system that it came from. Because, as scientists have known for a very long time, asteroids and comets are basically leftover material from the formation of the solar system, and their surfaces are bombarded by cosmic rays, solar radiation, and are battered around by billions of years of evolution and collisions. So while the outer surface doesn't really tell you much about the early days of the solar system in question, if you dig beneath that, you will find perfectly preserved material that acts as sort of a time capsule or a record of the ancient history of that system. And so what that shows us will basically say this is what the solar system it came from looked like when it was coming together, from which we can get a picture of what it's like today. In any case, as Atlas was approaching the Sun, and when it made its closest flyby to Mars in October, scientists were able to get a glimpse of what it's all about, what material it's ejecting, and there were some ambiguities which led to, once again, a controversial theory by Professor Abraham Loeb as to what 3 Atlas might be. And again, he emphasized that this was a thought experiment. However, this time around, his arguments they could be more easily countered with data pertaining to 3I Atlas, which indicated that no, it's most likely a comet. Nevertheless, back in July, Professor Loeb and other researchers from the Initiative for Interstellar Studies, they published a paper with the speculation that anomalous characteristics of 3I Atlas could be explained in terms of an extraterrestrial spacecraft. And their arguments included the fact that 3I Atlas was rather large in size, somewhat larger than what would be expected from a comet, as well as the spectra, which was ambiguous and at the time was not revealing identifiable chemicals. And of course, there was the trajectory of the object itself. Basically, 3I Atlas has been approaching the Sun almost in line with the solar ecliptic. And for those unfamiliar, the ecliptic refers to the solar equator, basically, and how the solar planets are very well aligned with that equator. They orbit along this path. And 3I Atlas, the fact that it was flying pretty close to that same line, that this was unusual and could indicate that this object had a proposed flight path similar to what we do here on Earth with our missions that we send out. They typically fly along the sun's ecliptic. However, other scientists emphasize that so far we've seen it outgassing, and that is very much consistent with a comet. And subsequent observations, which included those by the James Webb Space Telescope, they were able to determine the composition of that outgassing, and it showed CO2, water, and, as mentioned, high concentrations of carbon monoxide compared to objects in our solar system. And then the Swift Observatory, in August, they found evidence for water vapor, and there was some chemicals detected that were metallic in nature, and that included nickel vapor, which was detected by the Very Large Telescope in August, as well as cyanide. And as any scientist would tell you, all of these elements, this kind of composition, this is very typical of comets. And while its trajectory is a bit unusual, it is not entirely unexpected. So, in essence, the scientific community, they have been critical of Loeb's conjecture because, of course, they would say that the evidence he presented was not extraordinary. But at the same time, Loeb insisted that the most likely outcome will be that 3I Atlas is a completely natural interstellar object, probably a comet, which he noted on his blog, and also said that his hypothesis, it's a thought experiment, and it's an interesting exercise in its own right, fun to explore, irrespective of its likely validity. So yes, again, he stirred the pot on this, and I'd be remiss if I didn't also add that as someone who has spoken to Professor Loeb on many occasions in the past, and Adam Hibbard of the Institute for Interstellar Studies, who is co-author on many of these 3I Atlas papers, these papers came out at a time when the evidence was not yet coming in full force there, where we weren't seeing all the outgassing and spectra and so forth. And as he put it, personally, in a conversation with me, we were presenting a testable hypothesis that could this be an extraterrestrial spacecraft, and it was tested, and the answer was null result. It is, in fact, a natural object. So, yeah, once again, one could make the case for this being misinterpreted, that saying that Professor Loeb and his colleagues that they jumped the gun or that they suggested something irresponsibly may not be necessarily fair. And unfortunately, Loeb's stirring of the pot, it was received by some and interpreted by some as a claim that there was, in fact, an alien spacecraft on its way, and they ran with it, speculating that Atlas will, in fact, break apart when it's behind the sun, and an alien spacecraft will be revealed. And they've also argued that there's some sort of cover-up because scientific data is being held back. And this is based on the fact that when Atlas made its closest pass to Mars, it was observable by many missions that are currently stationed there. And of course, the European Space Agency, they released the data that they picked up from their Mars Express and ExoMars Trace Gas Orbiter, and China released the data it obtained from its Tianwen-1 orbiter. But what these theorists don't understand is that NASA cannot release the data from its missions because, of course, they're in the state of shutdown. And other missions did already reveal in the summertime that 3I Atlas has the properties of a comet, so there's really no conspiracy going on here. When the shutdown ends, NASA is likely to release all of the data from its Mars orbiters. And when it makes its pass around the sun, we will see it again, and with the increased outgassing that it will experience as a result of it making its closest approach to the sun, we'll get a chance to see what's inside. And what is inside will be essentially leftover material from the solar system where it came from. And that's going to tell us all manner of things about that system. And this, above all, is the beauty of interstellar objects. Because they are leftover material from their respective star systems, the study of them allows us to see what else is out there. And it's the next best thing to actually traveling to these solar systems, sending robotic probes out there. And as I said, the existence of such objects, it also has implications as far as the whole panspermia theory is concerned. And it is my guess that these objects do, in fact, contain the basic building blocks of life. We've seen that with near-Earth asteroids and comets before. We've seen organic molecules existing in all kinds of what we might consider unlikely places. Nebula clouds, stellar nurseries, and in these stray objects, which supports the notion that the ingredients for life are not only distributed throughout respective solar systems by their comets and asteroids, so it is absolutely, by extension, logical to think that the same process happens on an interstellar basis, that life is spread from one system to the next by these cosmic messengers. And the last thing I want to point out, which I referenced earlier, recent studies and observations of the interstellar medium, they've shown that rogue planets, which similarly, they are formed in a solar system, then kicked out due to gravitational perturbances, and they spend their lives floating through the interstellar medium and passing other star systems. And according to, again, a statistical analysis based on what we've seen, it's estimated that there are tens to hundreds of billions of rogue planets in the galaxy. That they're so plentiful, in fact, that, yes, if we travel through interstellar space, we may, in fact, find these giant planets, gas giants, or smaller rocky bodies. They, too, are flying around, and if, in fact, some of them are gas giants that have moons, similar to Jupiter and its Jovian moons, that those moons could, in fact, harbor life in their interiors because they've got warm water oceans due to all the tidal flexing in their cores, similar to Europa and Ganymede and also Titan and Enceladus around Saturn. If such moons exist around gas giants, if they're bound to the gas giants that are kicked out of their solar systems, then yes, they would be floating through interstellar space and could also be a means through which life is spread from system to system. And last but not least, recent studies have also shown hypervelocity stars, or just stars that are kicked out of their solar systems. either due to gravitational interaction with black holes or binaries that spin up and launch one of the pair out into space. And again, this is something that Professor Loeb has dealt with extensively, calculating the possible number of hypervelocity stars, and some which get so fast they're powered up by such powerful gravitational forces when they're ejected that they become intergalactic. But there are many that are within our galaxy right now, stars that are just moving about and making passes to others and causing disruptions here and there. But according to Loeb and a study he made roughly a decade ago, these stars may in fact still have their planets. They would still be gravitationally bound to the star, and so as it's flying out, its system of planets are flying with it. And if any of those planets are habitable and support life, once again, this would be a way in which these celestial objects could transport life from one place to another. And as I said, some are intergalactic, so it could in fact be that panspermia, it not only applies to solar systems themselves or in galaxies, but between galaxies. So yes, the implications for the study of interstellar objects, they are very, very consequential. And of course, ever since Oumuamua flew past Earth, scientists have been looking for ways in which we could create spacecraft that could be in a parking orbit around Earth and ready to go so that when another interstellar object is detected, it can rendezvous with it and study it up close. And there have been proposals for how existing missions, like the Juno probe, could in fact rendezvous with it and have a close-up look. And the European Space Agency right now is working on a mission called the Comet Interceptor. And the idea there is, yes, again, have a spacecraft or robotic spacecraft in parking orbit around Earth. And when a comet is entering the inner solar system, this ship would rendezvous with it. And it's non-specific as to what kind of comet it would be rendezvousing with. They could be long-period comets coming from the Oort cloud, or they could be interstellar comets. And so a mission of this kind, it would be the next step in this revolution in astronomy, the study of interstellar objects, because getting a close-up look, or dare we hope, putting a mission that can land on an interstellar object, the same way we've done with near-Earth asteroids now a couple times, if we could land on this interstellar object, we'd be able to dig deep, find samples from the interior, and this would be a sample return mission. They're sent back to Earth for analysis. And so we wouldn't just be detecting chemicals that are being released from this object when it's near to the sun. We would be able to look at intact samples of ancient material. And who knows what that could reveal. The point is, it would be the next best thing to going to this object's home system and seeing what's there. Sampling materials and analyzing them. The possibilities there are just really profound and exciting. And as for rogue planets on hypervelocity stars, that's a prospect. The studying of those particular objects or rendezvousing with any of them, that is something very, very far off. But it has to be noted. If these things are out there, they're also interstellar objects. So what can we learn from those? Even more profound. Especially if it's a unbound star with its system of planets, we would be going to another star system, but the beauty part is it's coming closer to us, so it would be a much more local trip rather than a massive interstellar undertaking. And so this is the state of our current scientific understanding there when it comes to interstellar objects. It is also the state of the crazy speculation that naturally emerges whenever scientific discoveries are made. And so it is important to debunk any theories that, yes, objects that are coming into our solar system from somewhere else could be alien spacecraft. It's like, yeah, that is a possibility, and it's an exciting one. And as Loeb argued, and I mentioned, space debris, the remains of a civilization or just the remains of a spacecraft that they sent out. It is entirely likely that we'll run into some of that someday. Just as the Voyager and Pioneer probes and New Horizons, all these missions that we've sent out, which have left the solar system, they will turn up in somebody's backyard someday. And given the age of our galaxy, given that humanity has only been around for the last 200,000 years, give or take, and has only been exploring space for a few decades, the likelihood that somebody else's trash or defunct missions, which were sent by civilization billions of years older than ours, that is a plausible possibility. But of course, as with everything else involving such grand speculation and conjecture, no matter how likely we think it is, that kind of extraordinary claim requires extraordinary evidence. And we haven't found it at all with the current census of interstellar objects. But we've only seen 3, so. And in the coming years, we are going to be detecting a lot more thanks to observatories like the Vera C. Rubin Observatory. And for years now, ever since Oumuamua was detected, and you'll see this in virtually every scientific paper on the subject of Oumuamua and Borisov and Three Eye Atlas, they mention the Vera C. Rubin Observatory because it is ideally suited to search for these objects. Its primary mission is to chart all the objects in our solar system, from near-Earth objects to asteroids to Kuiper Belt objects to all the families of asteroids that follow planets around, like Jupiter's Trojan and Greek population. And of course, as noted before, some of the interstellar objects that have entered our solar system in the past, but wound up staying because they got captured by Jupiter's gravity or the sun's or some other body and became bound objects. Scientists are already working to identify which objects that we know of that are out there, how many interstellar objects could actually have become part of these populations, and how we could identify interstellar objects that stayed through their particular orbits that would suggest that they, in fact, were captured, and perhaps even based on an unusual composition. Because, as I said, Three Eye Atlas did contain more carbon monoxide than is typical for comets in our solar system. So, dedicated missions could be sent out in the near future that could seek out identified interstellar objects and study them up close. So it kind of goes without saying that the detection of Oumuamua back in 2017, it set off a revolution in astronomy and in space exploration. Because now we have people planning missions that could actually intercept and go and study these objects. And the fact that we detected 2 subsequent objects in the 8 years that followed the first, that is indicating how our capabilities as a species, when it comes to studying objects within our solar system, that is an indication of how far we've come in terms of our instruments, in terms of our observation techniques. And with the Vera C. Rubin now operational, which released its first light images back in June, and other next generation telescopes coming online, and of course with James Webb in the meantime, able to track and observe objects that we detect, there's going to be a huge treasure trove of data, and scientists are going to be making all kinds of very fascinating discoveries in the coming years. And we can expect, with our improved instruments, that we're also going to be detecting a lot more of these objects. So it may get to the point where any interstellar object entering our solar system will be detected, and it's going to become something mundane because it's like 7 times a year or more we're hearing about another interstellar object, and oh look, it's an asteroid, oh look, it's a comet. And that, of course, is a very good problem to have. And who knows, we may find some incredibly interesting objects. We may detect something that really truly does fit all the parameters or ticks off all the boxes that says this is not a natural object. It can't be explained in terms of natural phenomenon. High hopes and long odds, but all we need is one detection, one artificial object that we can study, and we will have answered the most fundamental question we have. Is humanity alone in the universe? Are we the only civilization in the Milky Way, etc.? Myself and a lot of people were counting on the answer being no. Hard no, many times over no. And concurrently with all these detections and the new capabilities we have, Professor Loeb himself at Harvard University, they launched the Galileo project to observe interstellar objects as well as UAP with the express purpose of identifying technosignatures. So, looking for objects that are extraterrestrial in nature and potentially artificial. That is something that is also going to be happening in the coming years. So expect a lot of very interesting news, but at the same time, be sure to apply the scrutiny and the scientific method. And that, my friends, is interstellar objects and what the hype is about right now in a nutshell. And of course, as I hope I've made clear, the implications of these objects and our ability to study them, they will be immensely profound. And that's something I think we can all look forward to. And join me next time when I will be discussing the issue of panspermia further and the possibilities that it holds, and how it could answer the question, another fundamental question we have: how did life begin in the universe? How did it begin here on Earth? Where else could it be? In addition, be sure to tune in to Mostly True Alien Stories, a podcast that looks at the stories of alien abduction, potential cover-ups, government leaks, etc., and seeks to separate the science from the myth. The hosts, Neil and Andrew, were nice enough to have me on recently, where we discussed Three Eye Atlas and an incident involving a reported abduction, the Copley Woods incident. I will be sure to let listeners know when that episode premieres, but I encourage people to check out Mostly True Alien Stories on YouTube, as they have many fascinating episodes and talk about a wide range of very, very interesting case studies. In the meantime, thank you for listening. I'm Matt Williams, and this has been Stories from Space.